Hello everyone, my name is Debashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions, and I welcome you all to this webinar today. And today's topic is configuring Cisco device hardening and secure access control. Means how to secure your Cisco devices like the routers, switches, or controllers, or any other device, say the access points. How to secure the device, how to harden the security of your device. So let's begin. So we'll discuss how to secure device hardening and secure access control. So you have to secure your network infrastructure by minimizing attack services and preventing unauthorized access. So if you are using any Cisco device, say your router, and if somebody has actually break into it using the unauthorized password or unauthorized access, so how to secure that? Protect sensitive data and ensure network integrity for resilient environment. You have to understand the attack surface. First of all, you have to identify the common vulnerabilities. Say, whatever the weak passwords, default configurations, and say unpatched software cause risk. So you have to actually find out if there is password, or even if there is password, if the password is weak, if the password is not alphanumeric, or if it's not a strong password. So you have to say, maybe you have to give more characters to the password. Then your Cisco iOS, say it is unpatched. So you have to patch it, you have to upgrade the iOS. Then reconnaissance techniques, attackers gather information via scanning and enumeration on network device. So you have to be aware of these things also of the cyber attack, how the attackers are gaining the information or stealing the information from your device. Then the real world example, maybe the WannaCry and NotPeta exploited. So these are the exploitations that you have in the real world example, and Cisco weaknesses to spread globally. So these things happen. So you have to prevent it that nothing can happen in future. So you have to actually understand your attack surface. You have to understand how the attack is performed. What are the initial hardening steps for secure access? Number one, change the default password of the, say, modify enable console and VTI passwords, or the telnet access or the SH access. You have to immediately go to the strong ones. Then number two is use SHA 256 hashing. So that is a very strong algorithm, as you know, the SH algorithm. And set an enable secret password with secure hashing for password protection. Do not go for the enable password that is not encrypted. Always go for the enable secret. Now, number three is local authentication. Now, create usernames with strong passwords for device login. So, in that case, say for example, SSH login. So, in that case of SSH, you have to give the username as well as the password. So, you have to go for the local authentication and you have to enable the SSH. You have to implement role-based access control, means that privilege levels, you have to define roles from 0 to 15. That is, the 15 is the highest level of the password privilege level that you get. And command restrictions, assign specific commands to privilege levels with customized roles. And also, like the example is like network admins level 15, that is a full access. But in the case of help desk or desktop users, you give level 5. That is the limited. Means there are different levels of password that we know in Cisco, and you have to give the password privilege levels according to that. Secure management with SSH and console that I was talking about, like enable SSH, use RSA keys and strong domain names to secure remote access. Also, you have to disable the telnet, remove insecure protocols to reduce risk of interception. So you have to either go for the telnet or you can go for the SSH. But nowadays, the telnet is not so used much because of the weak password. So you have to go for SSH, but do not enable telnet side by side. You just disable the telnet in the line BTY. Also, the console security, use executive timeout and login synchronous for safe console sessions. So we have to monitor the console session also with this login synchronous command, as we know. So also you can execute the timeout also. Then implement AAA with Radius or TACAX Plus. So that is also the authentication, authorization, and accounting. Enable the AAA model for flexible authentication control. And you have to configure authentication, use Radius or TACAX for login, for fallback to local if unavailable. So all these things you have to configure if you want the centralized login server, centralized monitoring of the AAA. Set up authorization and accounting also, and you have to track user commands and access with proper configuration. So not only local authentication, but a centralized authentication should be there. If, say, for example, the WLC, wireless LAN controllers, will send the request of the AP, the join request, to the TACAX server or the radius. Network time protocol configuration, also you have to synchronize clocks of the NTP servers to keep device time accurate. Otherwise, say the devices or the routers will not update themselves or send updates. Source interface, set interface for NTP traffic to improve security and routing. And why the time matters? Because accurate timestamps help related security events and alerts. So these things, NTP configuration is very important. The setting the correct date and time. Otherwise, say for example, your routing updates will not flow. So this is very important. Then control plane policing or COPP, like control plane means your routing policy. Number one, protect control plane. So you have to limit the malicious traffic flow to keep your device control responsive. Because, say, for example, your router or your controller, say the control plane is transferred to the controller, and you have to implement strict control plane policing. Otherwise, say, for example, I am the attacker and I may send some update. So definitely you have to perform the authentication. Say the OSPF, BGP, AIGRP authentication for the control plane. Number two is identify critical traffic. Focus on essential protocols needing prioritization and control. So you may have to implement the QS also, quality of service here. If you are experiencing say congestion or you have to prioritize one traffic. Then number three is rate limit traffic. Means example is limit ICMP flooding to prevent DOS attacks. So if somebody is sending a too much ICMP traffic, you have to prevent that. You have to stop that. Logging and monitoring is also an important step. You have to centralize the login and also send system logs to dedicated syslog servers for analysis. Then set logging levels. So auditing and logging is also a very important part. Focus on warning, errors, information for relevant incident data. Monitor regularly. Then say use SNMP to track device health and detect anomalies early. So these things, logging, monitoring, auditing, should be in place. So we can conclude that continuous security monitoring should be there, ongoing hardening, because security is continuous, never stop improving device defenses, regular update of your software and firmware, like the iOS should be upgraded, periodic audits should be conducted to conduct the vulnerability assessment and adjust controls accordingly, and stay informed for the latest vulnerabilities and security developments. So these are the points to be noted for the device hardening and security control. So this is about the theory about the security part, and I can take you to the Cisco packet tracer, and you go to the CLI. Go to config mode and place enable secret password, say CCNA. So you are setting the enable secret password. You can set enable password also, say CCNP. So this should be different because this is for the device hardening. So the two passwords cannot be same, and enable secret is more secure because it's encrypted. So this will be effective, not the enable password. Also, you can set line console to prevent the console login. Say the password is say anything, say 1234, and then you have to give login to activate the password. Otherwise, the password won't be activated. So to log in for the console, that would be 1234 password you have to remember. And to go to the privilege executive mode, you have to give the CCNA, that's the enable secret password. Then copy run start, you save that and reload. And now verify whether it is actually hardening the security of the device, whether it is actually asking for the password. Yes, now it's asking for the password 1234, is all encrypted. And now you give enable and you have to give CCNA, that is enable secret. So there you go. You can see that we can set the passwords there. If you go to the show startup config, you can see that the enable secret and enable password is actually there. Ordinarily, you can also set the host name, so the CCNA, and IP domain name. This is for the SSH, say ccna.com, and then crypto, key, generate, and RSA. It will generate and modulus. For the SSH login, say maximum is 2048-bit encryption. And yes, SSH 1.99 version has been enabled. As you can see, you can go to line with UI 0 space 4 or any other user line, and you can give, say, transport input SSH. There it will only enable SSH, it will not enable telnet. Remember, you have to enable either one. And login local. So this is the way you have to set up the SSH password. So this is how you can enable the security of your device, harden the security. Also, one more thing I can show you. You have to set up the local username. Say username for the SSH access is, say, call, and password is CCNA. So when you are going to connect to the SSH, then you have to give this username call and password is CCNA. So this is a way to actually secure your device, to secure your, so harden the security of your device. You have to give the IP. One zero two. sh-l, and the login name was call, and it is 1002 asking for it is actually connection is refused. So I think the SSH is already enabled. Let me check. Line between 04 transport input SSH, and then the login local username call, password CCNA. It should be there. Okay, I think the IP is wrong. It is 1. Yes. Now, 2 actually was the IP of the PC. 1 is the IP of the router. And you can see that it is asking for the password. So, which is the password for this connectivity? So, just check it out. That is password is CCNA here. Yes, you have entered. So, this way you have entered the router. And again, you give the enable, and again it will ask for the enable secret. I think enable secret, just check me out. What is the enable secret password? I think it was this CCNA. Yes. So I've entered the router privilege executive mode. So this way, I've shown you the everything about the hardening of this security of the Cisco routers and other switches also. So it will be very helpful for your future studies, also for your Cisco networking, for CCNA and CCNP also. So you have to definitely follow these guidelines. You have to study this Cisco device hardening process and secure access control very meticulously for your exams, for CCNA, CCNP, and both, and also it will be very helpful for your future job prospect also. Because as you know, that security is paramount to networking and cloud everything. So you have to harden the security of your devices. Otherwise, the malicious attack, the outside attack will continue to disrupt and hamper and destroy your network. So if you deploy the devices there, routers, switches, controllers, definitely you have to make sure that no unauthorized access is performed because you have invested a lot on these devices. So definitely you have to make these devices a secure one. So I hope that you have got a good understanding on the Cisco device hardening and secure access control topic from this webinar, where I have discussed it theoretically and also I've shown you practically how to actually implement the passwords there, the enable secret, and the SH passwords there, and how to harden the Cisco security device. So I thank you all for joining and watching this webinar once again, and I come with some new topic next time. Till then, keep studying and bye.